All right, this is lesson 1 and 2 of Unit 2, and in this unit we're going to be talking about transformational geometry, which really means just how things move. In regular life, things move around. We throw balls across the room, we move our chair over to another area, we move our own bodies. And when we do those things, obviously certain things are not going to change. If I throw a ball across the room, when it reaches the other side, it's not magically an octopus or a rectangle. It's still the same shape and it's still the same size. Okay? And things in math move as well. And so we're going to be looking at different types of movements and also what stays the same and what changes when we do those movements. So there's a specific word for moving shapes in geometry. Moving a shape in geometry is called a transformation. So let's get down that vocab word. So transformation is moving a shape so that it's in a different position. So honestly, you just move a shape, and we call that a transformation. Now, there's 4 different types of transformations. In this unit, we're talking about 3 different kinds of them, and then in Unit 3, we actually will talk about 1 type of transformation. And there's a reason we break them up in that way. The 3 that we're going to be talking about, we call them isometries. So let's get that down. So isometries are transformations that do not change a shape's shape or size. And you might be thinking, well, doesn't that make sense? Anytime you move something, it's of course not going to be moving, it's not going to be changing its shape or changing its size. But you'll see this actually when we get to Unit 3. There's something called dilation, which you might want to think about as scale modeling. So you can take something that's a certain size and then kind of scale it down, and it's a perfect replica, but obviously the size is not the same anymore. You've made it smaller, or in the same way you can make things bigger and you can dilate it out. Okay, so that's Unit 3. But for this unit, Unit 2, we're dealing with only isometries. So when I move a shape, it stays the same. The side lengths stay the same, the angles stay the same, all that stuff, it's the same shape. We just put it somewhere else, or we maybe rotated it, or maybe we reflected it. Okay, those are the 3 that we actually will be learning about, and those are isometries, okay, because we're not really changing the shape, we're just kind of moving where it is. Now, when we're talking about isometries, we have these 2 words that we'll use to describe the first shape that we're using, and then the shape after it got moved. So the first shape is called the pre-image, okay? Let's get this down. So it's our original shape. So the shape we're starting with. Now let's say that I want to show that this shape is being moved over there. So maybe that shape's over here now. Okay? So that's the secondary shape. That's the shape that happened after I moved it, after I did an isometry to it. And so we call that image. It's what's there after you do the isometry, after I've slid it over, after I've rotated, after I've mirrored the image over. Okay? So you start with a pre-image, and then the image you get afterwards, after you move it, that's called the image. Okay? In class, I'll normally be coloring them pink and purple, just because I like how, by rainbow standards, you have your beginning and end, but you don't have to do it like that. You can color them whatever color you want, or you can even be labeling them something. So maybe you want to call this always like A in shape B, just to think this one comes first and then that one comes second. Okay. For this lesson, we're only going to be learning about one specific type of isometry, and it's one called translation, which pretty much means you slid something over. You just moved it over, but nothing else changes. So let's get that down. So translation is moving a shape without rotating or reflecting. You're just sliding a shape. Okay, so let's look at some examples. So here's my pre-image, and again, that means this is my starting original shape. So what if I want to just slide it over? Well, it might just get slid over to right there. So all I did to get from here to here was it got slid over, and that's translation. What if instead of sliding it that way, I slid it down? So it went from here, it just goes slid down. Translation. Okay? Maybe I slid it at an angle, so not that way, not down, but kind of going in a corner way, just going down like that. That's still translation. Okay? So if you're just sliding an image, it's translation. Okay? Now, if I give you a shape, and I ask you to translate it, well, you don't know what to do. I mean, that image could kind of go anywhere. There's kind of, as long as we don't rotate it, there's kind of anywhere that it could end up. So we use what's called vectors to tell us how far and in what direction to translate something. So let's say I want to translate this image by, let's say, by this vector. Okay, and while we're at it, let's get down a definition of vector, because I know it's probably been a while. So a vector has magnitude and direction. You're like, okay, that's nice. What does that mean? Well, the magnitude is how long you're moving something, how the distance you're moving. Okay, and direction is pretty obvious. So in this case, I want to move this image that far in that direction, okay? And the nice thing about putting vectors along a corner of the shape is it's really easy to match up where the image should go. So I can take this, and that same corner should line up with that end point. So you can see we moved it in this direction, that length, okay? So we just translated this image, this pre-image, that direction by that vector and got it to be here. Okay. Let's try another one. What if I wanted to translate this shape along that vector? Same thing, that bottom corner needs to travel that length in that direction. So even though it may not look okay to you that my shape is on top of it, if you think about it, that's exactly where that should be. Each one of these points, these corners, needs to move this far in this direction. So each of these points moved exactly that far. That one that went there, that one went down to here, this one traveled straight down to here, okay? And you can see almost that if we mapped out exactly where each of those points went to, you get that shape that we wanted. Okay? So when we're mapping out an image, when we're translating an image, each part of it is getting moved along that vector. Okay? Each corner, each side length, each middle section, all of that is getting moved that direction that much. Okay? Let's try another one. Let's try a tougher one. All right, let's say we wanted to translate this pre-image by this vector. Now, this is tough because this vector isn't connected to our pre-image. It isn't connected to our shape. So how do we know exactly how long that is? Well, we know the direction, and we can, of course, measure the length so that we know. So this is about 10 1/4. So I want to move each of these points 10 1/4 that way. So let's try it out. That point goes there. That point goes about there. That point goes about there. And that point goes about there. Okay? So I just took each of these corners, translated that length in that direction. Let's look at our image. And some of you might be thinking, that doesn't look like it's far enough. But you have to remember, this distance, this vector, says how far each point goes. It's not the distance between them. So if I take that image and move it 10 1/4, like I measured it, it actually really is that far. Okay, so you have to look at the distance traveled between point to point. So from here to here, here to here, here to here, and here to here, and obviously offset. So that's how you do it if the vector is not actually on the shape. You can just measure it out and you still can see which distance it is. We are now going to look at what is preserved, what is kept the same during translation. So we're going to be looking at all of these things. We want to check and see if the length, angles, orientation, which means which way it's facing, its size and shape, is going to stay the same when we translate it, when we slide it. So let's say we started with this image and we slid it over, we translated it, I don't know, maybe down to here. Okay? Now, during this translation, we need to check off which of these stayed the same, which of these were preserved. Okay? So let's take a look. Are the lengths the same? So was this length the same as this length and this side the same as this side? If I measured them, would they stay the same? Well, it makes sense that it would. All we did was slide it, so they should stay the same. So let's measure it just to be sure. Okay. This is 7 inches, so this guy should be 7 inches. And yeah, he is. Good. So yeah, lengths are still preserved when we translate. What about the angles? Do the angles stay the same when we translate? Well, I know that this part right here is a right angle, and so is this. So yeah, that looks like those angles stay the same, and this angle looks about the same as this one, and this angle looks about the same as this one. So yeah, the angles are preserved, so this angle stay the same. What about orientation? And orientation means it's still facing the same way. So is the short side still going this way? Yeah, that looks like it is. What about the next length side? Is that still facing down? Yeah, it still is. What about our longest side? Is that still facing kind of a corner direction going up? Yep. And each of our corners are still facing the same way as well. So yeah, the orientation stayed the same. What about our size? They look pretty much similar, which makes sense. All we did was move it. We didn't change its size. So if we took the area of this, the area of that should also be the same. So yes, size is preserved. And what about the shape? Well, they look, like the same shape to me. We still have a right triangle. And if we ever want to check it, you can always just overlay them again and be like, yeah, that's the same. You could cut them out and put them on top of each other and be like, yeah, it's actually still the same shape. So translation's a great one because everything stays the same. All we did was just slide it over. Okay? So everything is preserved. Everything stays the same. And that is lesson 1 and 2 of Unit 2.